Right, so here we're going to go through 1.3 exchanging data, the last part, part 5. Here we go. So we're going to look at these bits here. So capturing data, there are lots of automatic methods, from the magnetic strip on the back of your credit card, although nowadays there's a pin as a little chip inside it. Obviously, you've got barcode or QR reader, which are quite easy to implement, easy to print, put on goods. Obviously, that's mostly used in shops. You've got your NFC, near field communication reader. And remember how NFC works, which you did look at in another unit, is there's a little computer inside that gets powered by wirelessly, and so as you then go up to the receiver, it wirelessly gets powered, and then it can transmit the data. You've got optical character recognition, whereas where the computer will scan text and try and work out what it means. It's very good on printed text, but how accurate, comedy that I spelled accurate wrong there, on written text, but obviously it is getting better with AI, but still it's better with printed text. You've got optical mark character recognition, which is, if you ever play the lottery, although you might not have done, you just colour in the boxes on the numbers that you want, you feed it into a machine, and then it will detect the answers. It can be used on multiple choice forms, like if you get people to fill in a questionnaire, and they've got to fill A, B, C or D in, they colour in that box. The machine will scan it in, look to see if it's been coloured in, basically. If it has, then it reads it. It can be a very quick way to read in lots of forms or data, so it can be quite good. You've got magnetic ink character recognition, and what that is in, say, like a checkbook or mostly banking. What they'll do is they'll use ink that contains iron oxide, which is rust, okay? The same stuff they use in floppy disks, hard disk drives. Basically, rust has quite a good property in that if you magnetise it, it will stay magnetised for a long time. So what you do is as you put in the check into the machine, so they've printed like the sort code and the account number and all that sort of stuff in magnetic ink. And then a machine will magnetise it, and then it will read back the magnetised ink to get the data off it. Now, the main benefit of this is that it's human readable as well. Now, whether nowadays they could just use optical character recognition, given how good AI is and computers are now, and they don't need to bother with actually magnetising it, I don't know. I don't know how expensive the magnetising is. It probably costs nothing. And probably you'll find that the machines are already doing it, so it was cheaper to not change it. But there you go, that's what magnetic ink character recognition is. You print in an ink that can be magnetised and then read back. Right, so how do we get data into a database? Well, you can use a database management system, which we've used before with like SQL to get data in there. You can import it from another program, normally in something called a CSV file. Actually, if I get up a spreadsheet, so if you write some data in Excel, and then save it as a CSV file. I should have... there we go, comma delimited, but I missed. Comma delimited file, I call it book 1. There we go. If I then go into Notepad and then open up book 1, I don't know where I saved it, so this is not good. Let's just do all files, because it's probably not got CSV. Open book 1. I feel like that's too big. It seems far too big. What did I save it as? Let's do that again. File, I'd save it as book 1, but where did I save it? I saved it into my online one. That's not a good idea. So let's save it in documents, and we'll call it test CSV. So that's better. And then I'll open up the test CSV. There we go. And you can see it's what's called comma delimited text. So you can see here that it's made nothing, 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 nothing. But it's ignoring that one. So then you've got, data, a blank, blank. And it's an easy way to import data. Python supports CSV. Lots of things support CSV. I should have done better data there, because it would have made more sense to actually have like a title here and like some actual words. But just understand that the data would be separated by commas in comma delimited format. So that's one way of exporting data from a spreadsheet and then importing it into Access. Although you can import spreadsheets directly into MS Access. Obviously, it supports them. But anyway, there you go. But lots of programs will support CSV file export. So obviously you can type it into a form. A form could be online, could be linked directly with SQL, directly to your database, and people could fill it in. And there's something called EDI, which is electronic data interchange. I'll talk about that in a sec. So it's a common method for businesses to share data between each other. It's normally automatic and done over the internet. And it has a standardized message format to ensure compatibility, and documents are exchanged electronically. So it's a document exchange format that's got a standard to it, so everyone can do the same thing. Some software processes the data before sending to get the data the user wants. It's often used for sensitive data. For example, we get your exam results using an EDI. But yeah, there you go. That's it. So, right, now let's get on to transaction processing. So a transaction is basically any operation that you're doing to the database gets divided up into little transactions. So that could be to sort of move £30 out of one account or one column field and then put it into another place in a database, right? So that would be a transaction. So they, in a database, they must be either completely completed or fail. What you don't want is to take £30 out of one account but not put it in the other, and then you end up with stuff disappearing. This would really, would ruin the integrity, is what called, of the database. If you see the word integrity, it's the safety of the data in it. Is the data accurate? Has it been kept accurate? Is it safely processing the data? Because databases can be scary if you don't do them right, because you can lose a lot of money and stuff with missing out. So, these are the 4 things you need to be careful of when you're worried about your transactions. They can either create, read, update, or delete. They're your 4 things that transactions can normally do. And we've done those similar things in SQL. We've created data, we've read data, we've updated data, and we've deleted data, right? So there you go. So how do we keep the database integrity? Well, we use these rules called ACID rules. And here's what they mean, and I'm just going to read them out and go through them. So atomicity, it means a change must be fully completed or not at all, which I mentioned before. Anything half completed must not be saved. If you want to know why it's atomicity, it's because atom used to be what people thought was the single smallest thing ever. In fact, atom, the word atom comes from the Latin. I think it means no cut, like in appendectomy. So no cut, atom, no cut, because they couldn't believe that you could cut it. But obviously we found out later, Einstein and others found out that you can cut it in half and other things of atoms. But at the time in history, they thought an atom was the smallest thing ever. And so that's why it's saying that this transaction must be completed. It can't be half done, because they believed that atoms couldn't be half, although we now know that's not true. Consistency. So the database must be maintained. If you deduct money from one account, you must decrease it in the account it's going to. Now you might say, hold on, that sounds like atomicity. You just said don't complete a transaction. But what we're trying to say is don't make a transaction that doesn't do the correct thing. So here it's saying complete all transactions, but what if you create a stupidly wrong transaction where you create a transaction that forgets to put the money in the other account. So this one is saying ensure all transactions are completed, and this one is saying ensure all transactions maintain the state of the database. Like you've designed the transaction, the SQL query, to do the right thing. Okay, this is saying make sure the system completes the SQL, and this is saying make sure you don't design stupid SQL. Right? Isolation. Transactions must be done in isolation. Other transactions shouldn't interrupt them, and this is normally done using something called record locking, which we'll talk about in a minute. So basically, transactions are individual things that get completed individually, and then another transaction happens after. You don't sort of combine them and do 2 at once or whatever. You can do 2 things at the same time if they're not touching the same data, but of course, if they're touching the same data, then there's a problem, and we need to look into that. And then durability. Any change to the database must be safe from a system failure, e.g. a power cut. So the database, for example, shouldn't cache the data, and it should write it straight to the secondary storage. It's part of the reason, actually, that when you start a database program, you immediately have to save it. Right? So as soon as I start blank database, it goes, where are we saving it? Oh, I've just clicked too quick there. I'll do new. So it's saying there, I click blank database, and there you go. It's asking where are we saving it, what are we calling it. So it's gonna as soon as I type data in, it's gonna save it. As soon as I press enter, it's gonna save it. Whereas what would happen in say PowerPoint is it would save when I press save or every now and then. This is not acceptable in a database, so that's one of the things it means when it says durability. Right, so how do we stop the 2 things accessing the same data at the same time in a multi-user database? That means more than one person using it, which is very common. Every website you use is a multi-user database, probably. So one problem is that you could be trying to change the data at the same time. So what we do is we lock the data being used, and the other transaction would wait until it's finished. But you can get a situation called deadlock. And what happens here? Let's say we've got some data A and B. Right? They're 2 accounts. Barclays account, Santander account of 2 different people. One transaction is trying to move money from A to B, and the other one is trying to move money from B to A. So they both go at the same time, and transaction 1 says, right, I'm reading from this one, and it locks A. Transaction 2 reads the balance from B and locks B. Now they then both go to the alternative account to try and use them, but they're both locked. And essentially they will sit there forever waiting for the other transaction to finish. But because they're both waiting for each other, no one will finish. This is called deadlock. And there are ways around this, but it's just an issue you've got to talk about. It could come up in the exam. But yeah, I definitely think I'll ask it in the mock. So how do we do it? Well, one way is using serialization, okay, and that's to stop transactions overlapping. And one of the main ways to do that is something called timestamp ordering. So after a transaction, my typing, this has been terrible. After a transaction starts, we give it a timestamp. And then if any transaction affects the same data, we go with the transaction with the early timestamp. Okay, so if two things are accessing it, you go with the early stamp. So now what you've got here, so that's what happens. That's a theory, right? So let's actually look at it in practice. So let's say, I'll paint up. This will be top drawer. Let's say we've got a field called balance, right? It's in the person's balance, right? Then we've got transaction called, I'll just call it 1. Transaction, sorry, it's just the worst ever. Transaction 1, right? So this has got some data around it. It's got the last time it was read, which means someone's read the data from the transaction, and the last time it was written to, which means the last time it was changed or possibly changed, right? So we move those out of the way. So let's say then they've got no timestamp right now. So transaction 1 reads the balance from here, right? So it is on my clock right now, 10:43. So this would then get 10:43, and this would just store that it read it at 10:43. Right. Now, transaction 2 comes along, and transaction 1 is getting some data from somewhere else and waiting. So, you know, it's waiting for some data from somewhere else to do something. So it's just sitting there. Now transaction 2 goes, hold on a minute, I want to use the balance, right? So I'm going to write or something to this balance, or do whatever. It's going to write to this balance. So it's going to write to it at 10:45. Okay. So now when transaction 1 goes back to look at this data, or transaction, I know what I'll do. Actually, I'll say transaction 2 reads from it, actually, because that's more common. So transaction 2 reads from it at 10:45. So now this has been read at now 10:45. And so when this transaction 1 comes back, as it sees that the read, it doesn't match what it does, it knows that something else is trying to use that data, and it can then wait around. So that's essentially what timestamp ordering is. The only thing is, obviously, you need to have a read and a write timestamp for each object, which could obviously add more data, but obviously you get the benefit of not having deadlock, because people will do it by time, not by who accessed it last. Well, not by locking it until something's finished. Okay. So another way of doing this is commitment ordering. And then that's based on dependencies. It's not really well described in the book, and I don't know if it will be in any exam. But basically, the idea behind it is you prioritize based on what things are dependent on it. So if you've got less dependencies, then you would have more priority or something like that. It depends on how they set it up. And by dependency, I mean the data dependency is like what data depends on that data. So balance, for example, not much would depend on balance. But if you were editing, say, a foreign key, more things would depend on the foreign key, because other data depends on that data. Okay. And then basically this one will do it in that order, and then one will get completed before another one comes in. So things are ordered in dependency and then fully completed. Yeah, I mean, it's not a great one to talk about, but there you go. So last but not least, other safety measures required is something called redundancy. Now, this is a weird word because it doesn't sound like what it means. But basically, it's the act of having backup systems, software, and things in place to ensure that if there's a hardware or software failure, you've got a backup method. So, for example, you have a lot of redundancy in like a pacemaker in the heart. If one motor goes, I'm sure they've got another one, even if it's just a short-term one until an operation can be done or whatever. If the battery goes in the pacemaker, I'm sure they've got a second or third battery to have an alternative, and that's redundancy. It doesn't sound like the word because obviously you think redundant as out, useless, but that's what it means. And there you go. So that's that unit finished. Then good luck.